Number 6, a review, Kinematics Review worksheet. And we're trying to figure out, we're trying to find the two possible angles that we could aim at to hit this target 100 meters away if the exit velocity of the bullet is 450 meters per second. Okay, so I know that horizontally it's constant velocity motion, and that would be given by v bar t. And that v bar we're talking about is in the x direction. And so that's going to be 450 meters per second times the cosine of some angle theta. And then times time is going to be equal to that displacement of 100 meters. In the vertical motion, I know it's going to be constant acceleration. And really what I'm looking at for this is I need to figure out what the time is. So I can kind of plug it in over here. I know that the time up will be the same as the time down because it's over this nice level ground, same elevation, target, and starting spot. So I'm going to go ahead and use the idea that Vf equals Vi plus At on the way up. The final velocity up will be 0. And that's going to be equal to 450 meters per second times the sine of theta plus the acceleration, which is a negative 10 meters per second squared times t. I could solve this for t, and I get 450 meters per second times the sine of theta divided by 10 meters per second squared will be equal to that t, or just simply 45 seconds times sine of theta. I could plug that in right here, except I have to double that, and so instead of being 45, it'll be 90. And so we get 100 meters equals 450 meters per second cosine of theta times 90 sine of seconds times the sine of theta. So I'm going to go ahead and I think pull out a 2 here. So I'm going to get 100 meters equals 450 meters per second times 45 seconds times 2 cosine of theta sine of theta. The reason I did that is because 2 cosine theta sine of theta, we could replace that with the trig identity of sine of 2 theta. And then I would have this 450 meters per second times 45 seconds. And then 100 meters here. And so now I can go ahead and rearrange this and solve, and for theta I end up getting 0.14 seconds, or 0.14 degrees, pardon me, 0.14 degrees. Remember that there's 2 angles that we could get the exact same range, such that when they add up together to give us 90. So in other words, if I do 90 degrees minus 0.14 degrees, that will give me the other angle, and that is 89.9 degrees. So those are my 2 answers.